Today we're going to look at the first day of 12.5, nonlinear systems. So what this means is basically what you saw in 12.1 was linear systems. So either your system had one solution here, no solutions because they were parallel lines, or infinitely many solutions because the equations represented the same line. Today what we're going to be looking at is how parabolas intersect with circles, how ellipses intersect with lines, what it looks like when a circle intersects a hyperbola. So we're going to be looking at nonlinear, so circles, ellipses, parabolas, hyperbolas, how those work together. All right, so here's our first example. So we're going to solve these algebraically, and we're also going to solve them graphically. So in order to solve them graphically, you're going to want your calculator, and then I'm going to just show you some images here of how you might type that in. So let's go through how we would rewrite these equations so we can put them into our calculators more easily. So what you're going to want to do with all equations is solve for y. So for this first equation here, we're going to do negative y squared equals 4 minus 2x squared. Subtract that 2x squared from both sides. Divide by that negative. So we're going to get y squared equals positive 2x squared minus 4. And then we have to take the square root. So y equals positive or negative square root 2x squared minus 4. So if you want to type that into your calculator, you are going to look at typing in two different equations, positive 2x squared minus 4 and negative square root of 2x squared minus 4, just like that, into your y equals menu. And you will see down here in the actual graph, that's going to be the hyperbola, right? Because there's a minus in between. So that's represented by this hyperbola right here that I highlighted in green. All right, then what we want to do to be able to put it in our calculator is solve for y for this other equation, which is a circle. So y, whoops, let's do this in pen, not in highlighter. There we go. Y squared equals 8 minus x squared, and y equals the positive and negative square root of 8 minus x squared. So then again, to type that in, you're going to do a square root of 8 minus x squared, and then a negative square root of 8 minus x squared in your calculator. And then you will see here, you have that circle right there. Now what we're doing by solving this is looking where those intersect. So we are finding essentially these 4 points where those intersect. So we will get 4 solutions for this. Okay. All right, so what we're going to do is use some substitution. So if I'm looking, all right, if I'm looking down at my second equation that I wrote down here, I'm going to look at solving for y squared. So I'm going to use this equation right here and do y squared equals 8 minus x squared. And that's going to end up replacing that y squared right there. So we're looking at 2x squared minus 8 minus x squared equals 4. So we have a 2x squared minus 8 minus a negative x squared, so it's like plus x squared. So we end up with 3x squared minus 8 equals 4. Add 8 to both sides, you get 3x squared equals 12. Divide by 3, x squared equals 4. So x equals positive or negative 2. All right, so once we get that, to make this a little easier here, I am going to erase what's up here since we already went over that. All right, we got plus or minus 2. So when x equals positive 2, what does y equal? And when x equals negative 2, what does y equal? All right, so when x is positive 2, use one of our equations. I'm just going to use x squared plus y squared equals 8. So 2 squared plus y squared equals 8. Y squared equals 4. So y equals positive or negative 2. So we have two possibilities here. We have positive 2, or positive 2, negative 2. And then when x equals negative 2, most of you will probably be able to see this isn't going to actually end up with a different solution, because negative 2 squared is 4. So we get y squared equals 4. So y equals plus or minus 2. So again, negative 2, 2, or negative 2, negative 2. Okay? So those are our 4 solutions. And if you look over at your graph here, this is going to be the 0.22. Down here, this is going to be the 0.2, negative 2. Over here is negative 2, negative 2. And then up here is negative 2, 2. So you can see those are our 4 solutions. All right, so solve this system of equations algebraically and graphically. So here it is graphically. Again, you're going to want to make sure both equations are solved for y. So I'm going to look at solving this equation for y. If we subtract x squared, we get negative y equals negative x squared. So positive y equals positive x squared. And luckily on this one, the other equation is already solved for y. So as you can see here, we have a straight line, y equals 3x minus 2, and then the parabola, y equals x squared. So those ones are pretty straightforward when you type those into your y equals menu. They should be relatively easy to do since there's no plus or minus on your calculators. So I zoomed in a little bit because it's kind of hard to tell. So we're looking for our solutions that are here and here. Now, it's hard to tell on the graph. You can do the second, calc, intersection, all of that stuff. I'm going to do it algebraically and just confirm by looking at the graph that that is correct. So if I know y equals 3x minus 2 and I know y equals x squared, essentially what I can say then is that x squared equals 3x minus 2. Since both of those expressions are equal to y, that means they have to be equal to each other. So then x squared minus 3x plus 2 equals 0. Now that it's equal to 0, I can solve this as a quadratic. So this is going to be x minus 1 times x minus 2. So my two possible x values are going to be 1 and 2. When x equals 1, I'm going to opt to use this 3x minus 2. You could use y equals x squared, but you're going to get y equals 1 and y equals 4. So this solution covers 1, 1, and this solution covers 2, 4. So this is the 0.11, and this is the 0.24. And you can confirm that by doing second trace to calculate an intersection point. All right, and then lastly, solve this system of equations algebraically and graphically. So if you'd like to, I have the graph here, but I'd like you to maybe pause here, see if you can solve these equations for y, and then put them into your graphing calculator. Try and use your second trace function to see if you can calculate those intersections. Otherwise, try and do it algebraically too. So pause here, take a break, and see if you can give it a try. All right, so this might not look like it really intersects, but these are the two equations you should have gotten. Now remember, when you type this y equals plus or minus square root 25 minus x squared into your y equals menu, you have to do two separate graphs, really. You have to do a positive root 25 minus x squared and a negative root 25 minus x squared. And then the other equation you got was the inverse function, just stretched and reflected by 12. All right, so then from there, we need to essentially get these equal to each other, right? So since we've solved these both for y already, negative 12x is y, and so is this positive negative root 25 minus x squared. So I'm going to take those and set them equal to each other. Now, in order to solve this, I need to get rid of that square root, so I want to square everything. So I get 144 over x squared equals 25 minus x squared. Then I'm going to multiply both sides by x squared. So that cancels out the x squared on the bottom. So we get 144 equals 25x squared minus x to the fourth. And then if we rearrange this a little bit, we will end up getting x to the fourth minus 25x squared plus 144 equals 0. Now you might be looking at this and thinking, okay, how is this possible? How am I going to factor this? Well, if you look at the powers here, the 4 and the 2, since those are squares of each other, because normally we would say what, x squared minus 25x plus 144 equals 0, right? Well, it's the same thing. Since these are, since this 4 is double that 2, since this is x to the 4th, this is x squared, we can actually factor this like normal. We're just going to be using x squared instead of just x. So multiples, factors of 144 that will add to be negative 25 are going to be negative 16 and negative 9. So we're going to end up with x squared minus 9 times x squared minus 16 equals 0. This factors to be x plus 3 times x minus 3. Whoops, not 4, 3. And then this factors to be x plus 4 times x minus 4 equals 0. So our x's are going to be, we have 4 of them, x equals negative 3, x equals positive 3, x equals negative 4, and x equals positive 4. So now we just have to find the y values that are associated with each of those x values. So when x equals negative 3, I'm actually just going to use this xy equals negative 12. Seems a little more straightforward to me, but you can use the other equation too. So negative 3y equals negative 12. So if we divide by negative 3, we get y equals 4. So the point negative 3, 4 is one solution. And if you go up here, you can see at about negative 3, 4. Those are intersecting. All right, then we get 3y equals negative 12. So y equals negative 4. So then 3, negative 4 is a point. That's a solution. And that's shown right here. And then x equals negative 4. Negative 4y equals negative 12. So y equals 3. So negative 4, 3. That looks like that's right there. And then x equals 4. 4y equals negative 12. So y equals negative 3. So 4, negative 3. Oops, I mixed those ones up. So this is 4, negative 3, and then this one is 3, negative 4. Okay? So there are your 4 solutions. And if you did second trace and did the intersect calculation, those are the 4 solutions you would see. All right, so that's it for the first day of this. Tomorrow will just be a couple more examples with a little extra practice with some different types of solutions. So go ahead and get started on that worksheet 12.5. Do what you can. And that daily task on Schoology today should only be 1 question. So it should be relatively quick.